The gram formula mass, GFM, of a substance is known as the mass of 1 mole. Not the mole that you'd find in the ground, but meaning one of that particular substance that we look at when we work out the formula. The relative atomic mass of selected elements can be found on page 7 of the N5 SQA data booklet. These can be used to calculate the gram formula mass of a substance. This lesson focuses on working out the gram formula mass for 1 mole of a formula for a transition metal compound and basic 3-element compounds. We've got a set of rules that we have to follow. Step number 1, we need to write down the formula for your compound using SVSDF or prefix formula and put a box around it. Now the formula will usually be given to you in past paper questions. Step number 2, we have to write a list of all of the elements that you have in the formula. 3, identify how many of each element you have by looking at the number directly after the chemical symbol. Remember, if there's no number, that just means that you only have one of that particular element. We then have to use page 7 of the SQA data booklet to identify the relative atomic mass of the element and multiply it by how many you have. And the last step is to add up the total mass, which will equal the GFM, or the gram formula mass. Write the gram formula mass for zinc to carbonate. It ends in 8, so we're going to use page 8 of our data booklet. We start off with our SVSDF. The chemical symbol for zinc is Zn, and the valency is 2, which is given by the Roman numerals. Carbonate, the symbols are CO3, and we need to remember to keep a bracket around that. It's got a valence of 2. Swap the valencies over. What's the highest number both can be divided by? We divide it by 2. 2 divided by 2 is 1. 2 divided by 2 is 1. Which means that the chemical formula for zinc 2 carbonate is Zn bracket CO3 close bracket. We could remove the brackets, but for this example, I'm just going to keep the brackets in there. To work out the gram formula mass, we have to take down each of the elements. So Zn, how many do we have? We have 1. We look up page 7 in our data booklet and we see that the relative atomic mass is 65.5. 1 times 65.5 equals 65.5. Carbon, how many do we have inside the bracket? We have 1. Multiplied by the number outside the bracket. There's no number outside the bracket, so that's 1. And then we multiply it by the relative atomic mass, which can be found in page 7 of the data booklet, which is 12. 1 times 1 is 1. 1 times 12 equals 12. Oxygen, how many do we have inside the bracket? We have 3, multiplied by the number outside the bracket, which is 1, multiplied by the relative atomic mass, which is 16. 3 times 1 is 3, 3 times 16 equals 48. When we add all these numbers up, we get a gram formula mass of 125.5 grams. Write the gram formula mass for sodium sulfate. So we start off with our SVSDF. Symbol for sodium is Na. It's found in group 1, valency 1. Sulfate, we use page 8. The symbols are SO4, and we need to remember to keep a bracket around that. The valency is 2. We swap the valencies over. Highest number both can be divided by to keep it a whole number is 1. So the chemical formula is Na2 bracket SO4 close bracket. Again, we could remove the brackets, but we're going to keep them around here for this example. So to work out the GFM, we have to take down each of the elements from the formula. Sodium has the symbol Na. How many do we have? We have 2, multiplied by the relative atomic mass, which can be found on page 7 of the data booklet, which is 23. 2 times 23 equals 46. Sulfur, how many do we have inside the bracket? We have 1, multiplied by the number outside the bracket, which is 1, multiplied by the relative atomic mass, which is 32. 1 times 1 is 1. 1 times 32 equals 32. Oxygen has the symbol O. How many do we have inside the bracket? We have 4 multiplied by the number outside the bracket, which is 1, multiplied by the relative atomic mass, which is 16. 4 times 1 is 4. 4 times 16 equals 64. When we add all of these up, we get a gram formula mass of 142 grams. Write the gram formula mass for ammonium carbides. This one's a little bit tricky. We want to start off with the SV/SDF. Ammonium is not an element, so we have to use page 8 of our data booklet. The symbols are NH4, and we need to keep a bracket around that. It's got a valency of 1. Carbide, that means we're working with carbon. The symbol is C. It's found in group 4, valency 4. We swap the numbers over. Highest number both can be divided by to keep it a whole number is 1. So the chemical formula is bracket NH4, close bracket, 4, C, and we've only got one of those, so we don't write ones. We need to remember to keep a box around it. To work out the GFM, we have to take down each of the elements. We start off with nitrogen. The symbol is N. How many do we have inside the bracket? We have 1 multiplied by the number outside the bracket, which is 4, multiplied by the gram formula mass, which is 14. 1 times 4 is 4. 4 times 14 equals 56. Hydrogen, symbol H. How many do we have inside the bracket? We have 4, multiplied by the number outside the bracket, which is 4, multiplied by the relative atomic mass, which is 1. 4 times 4 is 16. 16 times 1 is 16. Carbon. How many do we have? Well, there's no number directly after the symbol, which tells us we have 1, multiplied by the relative atomic mass, which is 12. 1 times 12 equals 12. When we add those up, we get a gram formula mass of 84 grams. So there are 7 examples for you to have a go at. The first step you'll have to do is to work out the chemical formula for each of these compounds, and then you should be able to work out the gram formula mass. So if you want to pause the video, you can have a go, and when you're ready to go through the answers, you can press resume, and the answers will pop up on the screen. This question's from the Intermediate 2 2003 past paper, multiple choice 29. The formula mass of ammonium carbonate NH4 bracket 2CO3 is... Now let's work out the gram formula mass. Nitrogen, the symbol is N. How many do we have inside the bracket? We have 1 multiplied by the number outside the bracket, which is 2. And then we times it by the relative atomic mass, which can be found on page 7, which is 14. 1 times 2 is 2. 2 times 14 is 28. Hydrogen. How many do we have inside the bracket? We have 4, multiplied by the number outside the bracket, which is 2, times by the relative atomic mass of hydrogen, which is 1. 4 times 2 is 8. 8 times 1 equals 8. Carbon, the chemical symbol is C. How many do we have inside the bracket? We have 1, multiplied by the number outside the bracket. Well, there's no number outside the bracket, so we assume 1, times by the relative atomic mass, which can be found on page 7, which is 12. 1 times 1 is 1. 1 times 12 equals 12. Oxygen, symbol is O. How many do we have inside the bracket? We have 3. Multiplied by the number outside the bracket, there's no number, so that represents 1, times by the relative atomic mass, which can be found on page 7 of your data booklet, which is 16. 3 times 1 is 3. 3 times 16 equals 48. When we add all those numbers up, ammonium carbonate has a GFM of 96 grams.